Welcome back for the third part of the RGB Heart project. A navigation warning. The USB charger to be used is very important. For example, when I powered the board directly from my computer, it never detected a touch. I tried a few USB chargers I had around the house until I ended up using the one I showed in the programming part, as it works. This is probably related to the grounding of the computer or the chargers, so do not give up if it fails in the first attempts. Now, the board to be able to detect a touch, I will create a custom sensor, in this case a custom binary sensor. ESP-OM provides a general example for a custom sensor component in this page and a specific code for a custom binary sensor component in this one. Unfortunately, this approach is not recommended for new designs, as a new approach has been implemented. Nevertheless, it works and it is the only way I know how to implement this for now at least. To detect the touch, I will use the Arduino capacitive sensing library showed in this page. I have already downloaded the last version available. In Home Assistant, I went to File Editor. There, I clicked in the folder icon, then ESP-OM folder. Inside the ESP-OM folder, I created a new folder that will host my libraries and call it My Libraries. Inside My Libraries, I created a new folder and I call it Capacitive Sensor 0.5.1 Ifan Custom. I was getting an error using this library, but then when I started using the indicated version, the error disappeared, so it will not be changed. Then I uploaded the .cpp and .h files. Going back to the ESP-OM folder, I created a new file called mycustomtouchsensor.h that will contain the code of the sensor. I click it to open it. The code is this one. I will briefly explain it. Includes to import ESP-OM API and the capacitive sensor library, a variable to store the return capacitance of the sensor and other to store the current time of the program. Then the pins of the sensor are defined. Here the sensor is defined and the new code execution happens every 100 milliseconds. If a sensor needs other configurations to be initialized, then a priority needs to be defined. This priority can be found here. I used hardware because the sensor uses GPIO pins. For now, this line keeps commented. The initial time is recorded. Every 100 milliseconds the code here will be executed. Basically, a number of samples are read from the sensor. If that number is smaller than a predefined threshold, one can consider a touch has occurred, and the true state is published. On the other hand, if the read number is bigger than the threshold, no touch has occurred, and the false state is published. Finally, in order to see the values that are read, every 200 milliseconds a message is displayed in the logs. After the configuration of the H file, it is necessary to add code to the YAML file. The example code to add is shown here, and the code are these parts. The files to include and the definition of a new sensor. Attention, this name has to match the one in the H file. Saving and installing. The first thing to be noted is that the value retrieved should be giant, in the order of hundreds of millions. A big number will help finding a good threshold. If it is not, the board should be more isolated, like putting something plastic below it, or in this case a book with some fabric to not slip. This means that for this configuration the metal can no longer act as a support directly touching a surface. The next thing to note is the warning component took a long time. This happens because the reading of the capacitance is taking too long and it may compromise the normal functioning of the system. To fix this, I activate this line of code that sets a timeout of 20 milliseconds maximum, which is the time ESP-HOME recommends. Saving and installing. Now it is working. Let's check in Home Assistant and through the web server the functioning of the touch sensor. Now it is detecting well. We can get rid of the constant messages by changing the log level of the sensor like this. In summary, there are three important parameters, namely the timeout value, the number of samples, and the threshold value. Now I will put this new button to work. By touching the sensor, I want to be able to turn on and off the light, control the color and brightness, change the effects, and make it glow just white. To do this, I will use code from different ESP-HOME pages. From the binary component, I will use the onMultiClick, which allows me to define different types of touches to be detected. It is better to use this function instead of onClick or onDoubleClick because a double click can be interpreted by the program as two single clicks, and also because in this way there is more freedom to define the times to be detected. From the button component, I will use a function to activate the previous defined full white button. From the light component, the light toggle and light is on to change the light state and to check if it is on respectively, and finally from the automations and templates page, how to use the if cycle. The code is this one. For every type of touch, a message is displayed in the logs. Saving and installing. If I single click, it does not turn on. If I double click, it turns on. A single click turns on and changes the effect. Keep in mind that the last color active and the last brightness will be the ones that will appear when a more long click is done. In this way, I can use the effects to define the color and the brightness that I want. A even more longer click makes the board full white. In this way, I can control the board with only a button, in this case a touch button. Please keep in mind that some touches are not correct detected. Nevertheless, it really does the job. Let's just take a quick look of the board's power consumption. Powered on without an LED on, it consumes about 0.6 watt. When all LEDs are on and the brightness is 100%, it consumes 4.8 watt, which gives 960 milliamps of current. This is the power for different colors. If you have made it this far, thank you very much for your time. I hope this project has been useful to you in some way. If you notice something wrong or just want to give some feedback, please write a comment about it and I will be very glad to answer it. If you like this project, hit the like button and think about subscribing for more. Thank you very much for watching.